Hi, welcome to Nanyang Education's Primary School Problem Sum series, where we go through upper primary problem sum techniques. In this video, we'll be covering the basic techniques for part 7 of our series, Supposition. Under our problem sum technique playbook, we have 10 different techniques to go through, so don't forget to follow us for more content. So for this video, the lesson plan will be as such. First, we'll cover a basic question with a step-by-step guide. Next, we have another basic question for you to attempt on your own. And lastly, to really test your understanding, we have an intermediate question for you to try on your own. Now, without further ado, let's jump right in. So let's see our first question. There are 28 bicycles and tricycles in a bicycle shop. Each bicycle has 2 wheels and each tricycle has 3 wheels. That's obvious. There are 74 wheels in total, so how many bicycles are there? Now let's see. Our step 1 would be to identify the two variables, quantities associated with them, and difference. What does that mean? It sounds complicated, but it's actually quite simple. Basically, bicycles each have 2 wheels, and tricycles each have 3 wheels. Their difference would be 1 wheel each. For step 2, we suppose all the objects are the lower quantity. In this case, they are the bicycles. And then we find out the total number of wheels they would have. So let's assume the 28 are all bicycles. So we have 28 times 2, 56 number of wheels. Step 3, we should find the difference between the supposed and actual value. That will be 74 wheels in actual and 56 wheels that we assume. So that's 18 wheels. Now with this information in mind, we have difference per vehicle, 1 wheel. We assume all our bicycles, and we have our actual minus assumed to be 18 wheels. So using these difference, we can find the number of tricycles. We take 18 wheels divided by 1 wheel per vehicle, and we get 18 tricycles. So basically what that means is, we replace 18 bicycles with tricycles to get extra 18 wheels to cover the difference between assumed and actual. Now, depending on the question, we will have to find the other number of objects. Because we found tricycles already, now we can easily find the number of bicycles, which would be just the total 28 minus number of tricycles, 18. That will give us 10. So there were 10 bicycles. So now let's do a recap. So our first step will be to identify the two variables and the quantities associated to them. Then we find their difference, and let's call this difference 1. Next, we suppose everything is of the lower quantity, and then we find the difference between the actual value and our supposed value. Let's call this difference 2. Then we take difference 2 divided by difference 1, and we get the amount of the higher quantity. Now the question may ask for this. If it's as such, then this will be our answer. But if it's like question 1, then we just need to take the total minus our higher quantity to get the lower quantity. That way we solve the question. Now that we have learned how to do the questions, let's attempt another one. So there are 13 chickens and dogs at a park. Tom counts a total of 32 legs altogether. How many dogs were there at the park? Feel free to pause the video and attempt the question. You can resume once you're ready. Alright, so our first step would be to assume that all of them are chickens. So we get number of legs 13 chickens have would be 13 times 2 equals 26. Because as we know, chickens all have 2 legs. So now let's see the difference between actual and assumed legs. We would have 32 legs, as the question tells us, minus 26, as we have assumed. That will give us 6 legs. Now let's look at the difference in legs between each chicken and the dog. Now it should be common knowledge that a dog has 4 legs, so our difference should be 4 minus 2, which would be 2. So now we can find the number of dogs. That would be 6 divided by 2 equals to 3. So there are 3 dogs in the park. Now let's try a more difficult question. The total length of 30 long ropes and short ropes is 648 centimeters. If each piece of long rope is 30 cm and each piece of short rope is 9 cm, how many pieces of short ropes are there? Feel free to pause the video and attempt the question. You can resume once you're ready. Alright, so now I'll go through the question. First, we assume that all the ropes are short. So the total length of 30 of them would be 30 times 9 cm, giving us 270 cm. Let's look at the difference between actual and assumed length. That would be 648 minus 270, giving us 378 cm. Now we find the difference between each long rope and short rope. 30 cm minus 9 cm gives us 21 cm. So how many short ropes do we have to replace with long ropes? Let's see. Number of long ropes, 378 divided by 21 gives us 18. Now with the number of long ropes, we can find the number of short ropes. We just have to take the total 30 ropes minus 18 long ropes to give us 12 short ropes. So that's our answer. There are 12 pieces of short ropes. Did you get it? Thank you for watching. If you enjoyed the video, be sure to like, share, and subscribe. Bye!